Today I will be showing you how to create the minimum spanning tree of any given graph. Let's take this graph as the graph that we would like to make the minimum spanning tree of. To do this, we use Prim's algorithm. The visited nodes will be marked with green and the unvisited nodes will be marked with blue. First, we pick the starting node. In this example, we'll be picking A as our starting node, but it does not matter which one you choose. Now we examine all the connections that our starting node has with all the unvisited nodes. We can see that A is connected to B, to C, and to E. From these we see that the minimum connection that A has with any other node is with B, and thus we choose that one. Now we repeat the process, but we take into account B's nodes as well. We can see that B is connected to C and F, and that A is connected to C and E. You may have noticed that both BC and AE have the same distance. It doesn't matter which one we choose, and in this example we'll be going with B and C. Now we'll repeat the process once again. We can see that B is connected to F, C is connected to D, A is connected to E, and F is connected to C. You might have noticed that A and C have not been highlighted, and that is because both A and C are visited. We choose C and F because that is the minimum distance. Now, the connections available to us are C and D, A and E, F and E, F and D. From these, we choose FE. And finally, the two connections left are between C and D and F and D. From these, we choose C and D. Now that every node has been visited, we know that we have the minimum spanning tree. Let's go take a look at the Java code. And here is the code for Prim's algorithm. I have added a few comments to make things easier to understand and to make sure that you understand what part of the code does what. Just one thing that I would like to clarify is that to represent the connections we use an adjacency matrix, and any connection that does not exist is represented with a 0, or any connection of a node to itself is also represented as 0. Now let's take a look and see if it actually works. And yes, it does work. You may have noticed that there are different connections. That is mainly due to the fact that A and E and B and C are both 7.5, and in the example that I showed, I chose B and C. However, here the algorithm chooses A and E. It doesn't matter, the total distance is the same.